You have a particle, it moves along the x-axis. Here's your x-axis. Particles moving back and forth. Their velocity, this is the graph of your velocities. It's differentiable, so v is differentiable. Means it's continuous. Velocity, okay, the velocity is 0 at these three spots. It's pretty obvious. At this, this, and this, the velocity is 0. That's obvious. Horizontal tangent lines. So right here and right here, you have a horizontal tangent line. Doesn't apply to these two problems. And the area of the region, they tell you the areas of these regions are 8, 3, and 2. Remember, this is -8, positive, negative, because area under curves, negatives and positives. And the particle at time 0 is at -2. So, for this interval, find both the time and position, very important, of the particle farthest to the left. Justify your answer. So here we're going to go. Our particle started here. That's our starting point at -2. If I want to know when it's farthest to the left, what we got to think about, if it starts at -2, this -8 means it went -8 values, meaning so it's going to go all the way to right here. That is a 3-second time span. So x of 3 equals -10. Are we okay with that? X of 3 is -10. Meaning after 3 seconds, the value is -10. Next, from here, this +3 means it's now going to go this way. So now, it's going to take and go this way, 3. So that would take us right to here. So x of, how much time is this? Well, this is 2 more seconds, isn't that 5? So x of 5 is, what's it look like, -7? Is now -7. This is going to help with justification in a second here. And then this -2 means it's going to go back the other direction. Go to 2. So it's saying that x of 6, so 1 second later, it's going to be to the left, so that would be -9. So this is my little picture according to these areas. These are my x of values. Because the area under the curve are there. Now looking at this, where is it farthest to the left? That's pretty obvious. X of 3 is -10. We're done. So if we want to put it as a sentence, I put after 3 seconds. Is it time? Seconds? I think it's in time. Seconds. It doesn't say. After 3 seconds, it is at -10. That would be in a sentence. Now, how would I justify that otherwise? There are different ways to justify that, and you could actually find the values if you would do the integrals. Like you could set up this v of t, x of t is equal to, are we starting at -2? Plus the integral of blank to, isn't this t sometime? And won't this be v of, I have to use a different variable because if that's t, then you have to use a different variable. But v of x dx. So if that's my equation, could I also use this and find all those values that I drew up here in the picture? This would be the formula to find them all. And could you just keep trying values and figure out which is the biggest, which is the smallest? Plus, won't this tell you maxes and mins? Isn't this right here? What is this point right here? Isn't it changed from negative to positive? So what is this? Isn't that a relative min? Isn't that a relative min? Wouldn't this be a relative max? If relative min and relative max, because the slopes, these are slopes, velocities are slopes, negative, positive, positive, negative. These also help. So what you would do is you check this point in both endpoints. Would you technically go, I need to find x of 0, I need to find x of 3, and x of 6. Find all three, and then can you see which one's the biggest? That would be the technical way of doing it, farthest to the left. But I think it's a lot easier to just, oh, I messed up. Do you want to, relative min. This is farthest to the left, yeah. So you check all those. That would work. Now, the last piece, B. How many times is it cross negative 8? Look at this. Here's negative 8. How many times is it crossed? 3 times. And my justification, look at diagram.
That works.
Now, you can look at the diagram, plus you can explain it with this right here. But for now, I'm just going to say look at diagram because the bell's going to ring.